Hi everyone. Today we are moving on to the second part of the second cycle of Unit 6. So yesterday you took an assessment for the beginning of the unit, and today we are going to be moving on with the next part on circuits. So today we are going to do a quick introduction to circuits. For that, you are going to need your notebook. We're going to be doing some drawing and some modeling, so you'll definitely need that, and a pen and pencil. You'll also need your Google Classroom open, then the classwork document. In the classwork document, there's a link for a PhET simulation that you're going to need, so you should have that open as well, and then the SOS website if you're using it. Okay, take the next 30 seconds or so to make sure you have all of those tabs open. All right, so today we are going to answer the question, how does electricity flow and what is necessary for that to happen? We will look, we will make some observations, and then we're going to analyze them to help us make sense of this new phenomena we are exploring. As we learn about electricity, it is important that today we are prepared to draw models, like I mentioned before, so that you're going to draw models of what we observe to help us make sense of how electricity works. Okay. So our agenda for today is we're going to do a quick introduction to a new vocab. We're going to do an exploration, a quick check for understanding, and then there's some reading and a core idea and an Isaac ticket. Okay. So before we start with our exploration for today, we're going to define this new vocabulary word, which is essentially what we're going to be exploring today and in different ways throughout the rest of this unit. So electrical current is an electric current. So an electric current is a measure of the amount of charge that passes a certain location over a certain amount of time. So make sure that you write this into your notebooks, as this is a really important definition. So again, current is how much charge there is and how much of it is passing by over a certain time. So here I have two diagrams. So we see there's current is going to have a direction because it's charges that are flowing. And we might have a lot of current, which is represented by a lot of these dots. Or we might have a small current, which is represented by a few of these dots that are charges flowing. Okay? So please make sure you write this definition into your notebook, and also the drawing would be also helpful to have. You take the next 30 seconds or so to do that. If you need to press pause, you can also do that. Make sure you have it done. Okay, moving along. So now we are going to do an exploration. Which light bulb lights? So given one light bulb, one piece of wire, and one battery, how can you connect the three of them in order to get the light bulb to turn on? Okay, so we're going to use a simulation to see which setup would light or not. And then you're going to take notes in your observation of your observations in your notebook. So you can click on you can open up the tab for the classwork document. I already have this up here. So the way this works, I'm going to reset this. So you can drag from over here a light bulb. You're going to drag battery, and then you're going to drag out a wire. And using these three, how can we connect them in order to get the light bulb to light? So these circles here connect with each other. So just using these, and if you need to cut it, you just double click on it and this will pop. So then you just hit the scissors and they will separate it for you. All right, so then take the next 2 minutes to come up with 3 different configurations of these 3 objects and have at least one that lights up. All right, so press pause now in order to do this activity, and when you're ready, press play. Okay, welcome back, scholars. Let's come back to PowerPoint. So hopefully you came up with at least one method, one way for these to light up. Actually, sorry, I'm going to show you guys. So one way of having this light is you can connect the wire here to the battery. So now my wire and my battery are connected. And I'm going to move my light bulb closer. So now one side of my battery is connected to one side of the light bulb. And now I have one side of my wire connected to the other side of the light bulb. So here I see the current flowing. So the electrons moving around is my current that's flowing, and the light bulb has turned on. And if I wanted to stop it, then I can just cut it. So that's what your little circuit should look like. So coming back, you're going to take the next 4 minutes to answer the following questions in your classwork document. What do you think the purpose of the battery is? What do you think the purpose of the wire is? And what did you have to do to get the light bulb to turn on? Right? So when you're ready to come back, you can press play to rejoin the video. Press pause now. Okay, scholars, welcome back. We are going to answer those questions through your reading. So you're going to take the next 10 minutes to read and annotate the text that's in your classwork document for key points and definitions. While you're reading, look for the answers to the question that you just answered in your classwork documents. Again, when you're ready to come back and you're done with your reading, you can press play again. Press pause now. All right, scholars, moving on. So at the end of the reading, there are 3 questions underneath that we are considering our check for understanding for today. So the first thing you're going to answer is, what is an electric circuit? Then which 2 parts must all electric circuits contain? And then you're going to sketch a simple circuit that includes a battery, a light bulb, and a switch. Right, so that third question you're going to have to do in your notes. So make sure to include a picture of that in your classwork document at the end of the day. Take the next 5 minutes to answer these 3 questions. When you're ready to come back, you can press play to start up the video. Press pause now. Okay, moving along. Now let's make a few predictions. For which current will the light, for which circuit will the light bulb turn on? Select yes or no next to each circuit. So in your classwork document, take the next minute to decide whether these will turn on, which one will turn on or which one won't. When you're ready to come back to the video, you can hit play. Okay, and let's move on with our answers. So let's check our prediction. So hopefully for this first battery, you said that it will turn on. And let's see why. So in the definition for a circuit, you said that you have to have a battery, you use the word voltage source. The word voltage is something that we're going to be discovering in more detail tomorrow. And then it has to connect one side to the light bulb, and then the wire has to connect the light bulb to the other side of the battery. So we see that happening here, right? So there's a whole closed loop happening here. So then the current will be flowing. Okay, it's messy. Erase it because it looks messy. But we see that there would be a current flowing. For number 2, hopefully you said that this light would not turn on. And the reason why is because the wire connects the light bulb only to one side of the battery and not to the other. Right? So you have to have a connection to both sides. Right? So there won't be any current here. So the light won't turn on. And then for 3, this one you have to look a little closer to see what's happening. So we see the wire that's connecting the negative side of the battery to the positive side of the battery, but it's actually not touching the light bulb. So the light bulb is touching the battery, but the wire isn't connecting anything. It's just touching the battery itself. So here, this also would not cause the light bulb to turn on. Right? So you can go back into your classwork document and correct your predictions if you need to. Right? So the last thing we're going to cover is this core idea for today's lesson. So electric current is a measure of how much charge passes at a certain location over a given amount of time. Right? So again, current is electrons that are flowing, electrical charge that's flowing around over a certain amount of time. And an electric circuit is a closed or continuous path in which electrons from a voltage source or a current source flow. Right? So in all of the examples that we saw today, the battery is considered a voltage source. That was explained a little bit again in the classwork document, in the classwork reading that we're going to be doubling in more tomorrow. And then the circuit has to be closed in order for electricity to flow. If it's open, then it's considered an open circuit and there won't be electricity. Right? So make sure to write both of these core ideas in your notebook. And you can also draw this diagram to help you reference the difference between an open and a closed circuit. Finally, our exit ticket is going to be to draw a circuit with a light bulb and explain why your light bulb is able to light. You are essentially creating a model and explaining why your model works. You're going to draw your response in your notebook and attach a picture with your classwork document onto Google Classroom. I hope you guys find this lesson interesting. I'm pretty excited about what's to come. This is the first step for us to be able to delve into what electricity actually is. I think electricity is definitely one of those things that we take for granted the most, especially nowadays, because so much of our day-to-day is connected to electronics, but in general, we don't put too much thought into it. So hopefully this will give a little bit more perspective about just today's lesson, and the subsequent lessons to come will give us more perspective on how all the electronics that are in our house, how everything in the world is powered. So I hope you guys find this exciting. That's all for today. I hope you have a wonderful day and see you next time.